Hi, in this tutorial we are going to have an exercise related to drawing resonance structures for radical species. So let's start from option A. In option A, we have a cyclohexane ring with two pi bonds and a radical part. So how are we going to draw the resonance form? Uh, we have to know the general formula how to write resonance forms for different molecules. For example, if we have a pi bond and then if we have a sigma bond, and on the Z part of the molecule, if we have a special thing which can be a lone pair, or it can be an unpaired electron, or it can be positive charge, or it can be a negative charge, we can have a resonance form having XY now sigma bond, YZ pi bond, and the special thing moving on X. So if we apply this rule here on A, so I'm going to write the resonance form, and I'm going to move the pi bond over here, and the radical part it's here, and the other pi bond we didn't touch. So I'm going to use a different color for the pi bond that we moved. So this is the pi bond, so this is the radical part that we moved. So then again we can continue writing other resonance form, because we can have X, Y, Z system here. So if we apply the same principle here, this was already here, the pi bond should move here and the radical should move here. So again, I'm going to use a different color for the pi bond that we moved. So this one and this one. So how are we going to use curved arrows to show or to move from one resonance form into the other one? Okay, so in the first molecule, so basically we need to create a pi bond, but that pi bond can be created by shifting this radical, this unpaired electron here, and also one of the pi bonds of one of the pi electrons moving there to making the pi bond, and the other electron in the pi bond should move as an unpaired electron, so we can shift from A to B that way. So how can we shift from B to C if we label the resonance forms as A, B, C? Again, it is same principle. The unpaired electron should move to make the pi bond, and also we need another electron to make the pi bond there. So the one of the pi bond electrons should move there to make the pi bond, and the other electron of the pi bond should move on the carbon as an unpaired electron. So basically by using these curved arrows, but not full-headed arrows, but fishhook type arrows, we can write resonance structures for radicals. Let's do the same for the option B. Let's write just couple of resonance forms. Again, I'm going to label the molecule as XYZ. So the pi bond should move between Y and Z, and the unpaired electron should move on X. So let's just draw it. the first part of the molecule, we haven't done anything, but in the second part, so pi bond should be here and the unpaired electron should be here. Okay, then how can I use curved arrows? So let's use the red color for that. Again, unpaired electron should move between Y and Z. Okay, then also one of the pi electron should move there to make the pi bond, and the other electron on the pi bond should move as an unpaired electron. Okay, let's also do for option C. Again, we have to label as X, Y, Z. As you know, X, Y is a pi bond. We have a double bond. Y, Z is a sigma bond, single bond. Z has an unpaired electron. So if we apply the same rule here, the pi bond should move to between Y and Z, and XY should be a single bond, and the radical should be on X. So if we draw here the molecule again, like this. So this pi bond was already there. So here the pi bond should be there and the lone pair should be here. So how can we draw curved arrows? Again, with the red color we can show it. So the unpaired electron should move as part of the pi bond, and one of the pi bond electrons should move here to make the pi bond, and the other pi electron should move here as a unpaired electron here. Thank you so much for watching the video.